This appendix is designed to introduce you to discounted cash flow techniques and investment appraisal. You may have a gap in your knowledge due to a change in the CIMA syllabus, or perhaps it's been a long time since you've covered these techniques. It's essential that you are confident with everything in this presentation before we use these techniques in Stage 2 of the F3 course. We're going to start by talking about the time value of money. £1,000 in your hand now is not worth the same as £1,000 later. You'd actually be better off if you put the £1,000 into the bank account for a year. So you would prefer to have the money now. Discounted cash flow techniques take into account the time value of money, and that's critical when cash flows are going to be spread over several years. So for example, when you're appraising a project, there will be cash flows going into the future. And the whole idea of discounting is that we convert that future value into a present value. The present value of future cash flows is calculated by discounting those cash flows. And we're going to look at how we do that technique. The further into the future the cash flows occur, the lower the present value. Now, there's a few key terms that you need to be familiar with. The first very important one is the cost of capital, and this is also called the discount rate. It's the percentage that we use to do these calculations, and it's the return required by the providers of the finance. We're going to spend quite a lot of time calculating this later in the course. You also need to know how to calculate the present value of an annuity. And this is a series of identical cash flows that occur every year for a certain number of years. So for example, £1,000 every year for 10 years. A perpetuity is also a series of identical cash flows, but they go on forever, indefinitely. We now need to look at some formulae, which will help us to do these discounted cash flow calculations. Now, these are all given to you in the exam, so you don't need to learn the formulae, but obviously you do need to learn the technique. So let's start with the basic present value one, which looks like this: 1 over 1 plus r to the n, where r is the discount rate and n is the number of years that we're looking at. So let's have a look at this with an example. We've got £100 which will be received in 5 years' time. That's the future value. The discount rate is 10%, and we want to know what the present value is. So our formula that we're going to use is 1 over 1 plus the discount rate, which is 10%, express it as a decimal, 0.1, and do it to the power of the number of years, which is 5. We then multiply that by the cash flow, and that will give us the present value. Now, one little bit that you do need to be very happy with is your scientific calculator, and the power button on the most modern ones will look like that, or it may possibly look like that, or y to the x, or x to the y. But you need to be very familiar with how to use that power button on your calculator. With the modern calculators, you literally just tap it in as it looks on your piece of paper. So you put in 1 divided by bracket 1.1 power button 5, and that should give you 0.621. You can either use that formula or you can use the present value table, which will be given to you in the exam, and you can find it at the back of your course notes. If we look up the value of the discount factor for 10% at 5 years, you get 0.621. And that's the same as we had when we worked out 1 over 1 plus r to the n. There may be some rounding issues, which means that it's not always exactly the same, but this generally is a much quicker way to do these calculations using the tables. However, if it goes for more than 20 years, or the discount rate is more than 20%, or the discount rate is a decimal, you're going to have to use the formula rather than the table. Moving on now to how to calculate the present value of an annuity. And remember, this is equal annual cash flows, and they have to start at time 1 for a certain number of years. You've got this rather revolting looking formula, but in fact a much quicker way to calculate the present value of an annuity is again to use the tables. If we do an example again, and this time we have £100 every year for 5 years, an annuity, same discount rate 10%, and use the formula first of all Quite difficult to get that into your calculator, but remember to use the brackets. And what you get is 3.791 is the discount factor that you then multiply the cash flow by. And we can use the tables instead to make this quicker. This time we use the cumulative present value table, which again will be given to you, and you look up the 10% discount rate for 5 years, and that will give you 3.791, the same as we worked out using the formula. The final type of cash flow that you need to be able to deal with is a perpetuity, so that's going on forever, and it's a very simple formula. You literally just divide by the discount rate. The only slight problem here is often these in the F3 exam will be presented as a delayed perpetuity. In other words, you'll get to, for example, year 10, and from then on the cash flows will carry on. What you've got to do there is you take that 1 over R as your discount factor and then subtract the annuity figure for the periods before that starts. And that's a really important technique in your F3 exam. The other thing to be aware of is if you've got any form of growth rate in there as well. So if it tells you that cash flows are going to grow at a certain rate per year, the formula changes slightly. It's 1 over R minus G. And that's one that you need to learn. You won't be given that in the exam. This lecture example gives you 4 different types of cash flow present value calculations to do. Start with quite a simple one. So you've got a cash flow happening in year 6, just the one cash flow, and the discount rate is 15%. So go to the table, the present value table, and look up the discount factor for year 6, 15%, and you should get 0.432. Then all we do is take the future value that you're given of that cash flow and discount it using that discount factor. And that should give you 25,920. Then in part B, we've now got an annuity. You're getting contribution every year from years 1 to 10, and the discount factor is 11%. So again, go to the present value tables, but this time you want the cumulative present value table. Look up 11% for 10 years, and you should get 5.889. So again, all we do is we take the cash flow that's going to happen every year, multiply it by that cumulative discount factor, and you get a present value of 5,889. Part C gets a bit more complicated. You've got an annuity because it's costs incurred each year, but it's from years 3 to 6, so it's a delayed annuity. So that makes the calculation slightly more complicated. So we start by looking up the discount factor for years 1 to 6 at 5%, the cumulative one, and that is 5.076. But it doesn't start until year 3, so what we've got to do is to deduct the discount factor for years 1 to 2, also at 5%, and that then gives us 1.859. So if we take that away from 5.076, you get 3.217, and that is the discount factor for years 3 to 6. Now all you've got to do is to take the amount of the annuity, multiply it by the discount factor, and then you get the present value of that cash flow. Part D finally is that nice simple perpetuity formula. So all we do is we take the value of the cash flow, multiply it by 1 over R as a decimal, which is 0.15, and that gives us a present value of that cash flow of 4,000. We're now going to look at 2 different investment appraisal techniques, starting with net present value. A project is likely to have various cash flows occurring at different times during its life cycle. They could be positive or negative, and NPV, or net present value, is all of those cash flows all added together. So the definition of it is the sum of the present values of all the cash flows. There's an important part for later in the course here, that it represents the change in wealth of the investor, and that's going to be very important when we look at business valuations later in the course. The crucial thing first of all is to identify which cash flows are relevant to a project. So, for example, it needs to be a cash flow that's in the future, not past. It can't be a sunk cost. It has to be incremental, in other words, the extra little bit, and that'll be important when we look at investment in working capital. It's also got to be cash flow, not profit. So depreciation does not go in a net present value calculation. The tax effect of depreciation will do, but not the actual depreciation. That's a profit figure. Relevant costs can also be opportunity costs. And that's a concept that you should be quite familiar with from your earlier studies. But also they can actually be avoidable as well. And there we're talking about a shutdown decision. It's very important to read the scenario details really carefully and pick out which cash flows are relevant and which ones are not relevant and therefore won't go in the project appraisal. This table gives you the advantages and disadvantages of the NPV technique, and it's always important to be able to discuss techniques as well as to do the calculations. So the main advantage of it is that it's incorporating the time value of money that we talked about earlier, and it considers all of the cash flows of the project. The problem is always estimating a cost of capital, which we'll cover again later, and also making sure that you have got all of the relevant information. The decision rule that we go with on net present value is that you accept all projects with a net positive NPV. Before we move on to the second investment appraisal technique, which is internal rate of return, let's just have a look at lecture example 4 and go through how the NPV is presented and calculated. The first really important aspect is to lay out your NPV calculations in a tabular format with the years going across the page. The marker will like you if you present your calculations so that he or she can read them easily. So set out the years first of all, and then we start looking at the cash flows. The first cash outflow that we need to look for is anything that we're buying at the start of the project. So in this case we have got some capital expenditure. We've got $350,000 cost to take over the business and a further $150,000 for refurbishment. So that gives us a total of $500,000 which goes out right at the start of the project. And that means that that goes out in what we call time naught, right at the start. Because that isn't cash outflow, it's shown as a minus on your NPV calculation. The details in the question told us what the net cash flow was, so you literally just put those in for each relevant year. The business is going to be sold at the end of the project for $350,000, so that is also a relevant cash flow that needs to go in. So that's all of the relevant cash flows now, so we now need to look at calculating the present value. And what we need for that, first of all, is the discount factors from the present value table, and the cost of capital, we were told, is 12%. You then multiply each year's cash flow by the discount factor to get a series of present values. To get the NPV, you just add up all of those cash flows, so minus 500 plus all the other cash flows that have been discounted. And that gives you a net present value of 33.85. We've actually rounded our numbers up, so that's 33,850 as a positive net present value. So if we were just going to take that in terms of the decision rule, it's positive, therefore we should go ahead with the project. Net present value gives an absolute measure of what a project is worth. The second technique that we're going to look at is internal rate of return, IRR, and that gives an annual percentage return generated by a project. Still incorporates time value of money, the discounted cash flow techniques, and there's a step-by-step calculation that you need to learn, as well as a formula. It's really important that you do understand and learn this technique because you're going to use it a few times during your F3 course. What you have to do is to calculate two NPVs at two different costs of capital, and often we say start with 10% and then use, for example, 5% as the second one. The idea is that you are trying to find the cost of capital at which the NPV of a project would be zero. Again, there are some advantages and disadvantages of this technique that you need to be aware of. And we will look at this again when we look at the modified internal rate of return, which attempts to overcome some of the disadvantages of the usual technique. The decision rule then is to accept all projects with an IRR above the cost of capital. So let's now go back to lecture example 4, and if you remember, we calculated the net present value of Brenda and Eddie's project at 33.85, and that was at a 12% cost of capital. So to do the IRR, we need a second NPV using a second cost of capital. Now we can go either lower or higher, but in this case, because we've already got a positive one, if we go for a higher cost of capital, what we'll get hopefully is a negative NPV, and that will increase the accuracy of our answer if we have one positive and one negative. Not essential though, you can actually have two positive NPVs, the technique will still work. In this case then, we're going to now calculate the NPV at 15%. So first of all, we just start with cash flows that we had in the previous example. We then look up the discount factors for 15% for years 0 to 6. Multiply each of those cash flows by the discount factor to get the present values, and then the net present value is the sum of all of those. And that gives us this time a negative of 23.6. So now we need to use the IRR formula, decide what A, B, NPV-A and NPV-B are, and then put those figures into that formula to calculate the IRR. The only tricky bit to remember here is that you've got a negative NPV for NPV-B, so you've got a minus multiplied by a minus. So when you do this part of the calculation, you just need to remember to make that a plus. So the calculation of the IRR, if we put all those figures together, you get 13.8%. And the decision rule, remember, is to compare that with the cost of capital and to see if it's higher. Cost of capital is 12%, IRR is 13.8, therefore you accept the project. So to summarise, before you go any further with your F3 course, you need to be very comfortable with these investment appraisal techniques. You need to be able to calculate the present value of a cash flow, an annuity, a perpetuity, a delayed annuity and a delayed perpetuity. You also need to be able to do a basic net present value calculation so that you've got the building blocks that you need when they get more complicated with more detailed calculations to do. Finally, you need to be able to do an internal rate of return calculation, and again we're going to use that later on in the course.